Okay, so a more specific distribution, a probability distribution, is what we call a binomial distribution. And a binomial distribution can also be referred to as a Bernoulli distribution, and it has a couple of key features. All right, so with a binomial distribution, there's only two possible outcomes, and typically we classify it as success or failure. So success or failure could be rolling a 6 or not rolling a 6, getting a red ball or not getting a red ball, succeeding at a game, not succeeding at a game. Okay, so we often refer to them in terms of A and A dash, if you like. The other key attribute is the probability of success, normally given by P, is the same for each trial, so it doesn't change. So rolling a dice, tossing a coin, perhaps winning a game of football, just depends on the wording. All right. So if we have a scenario where we have a certain number of trials and the probability doesn't change, we can say that the variable or the probability can be distributed binomially and with NP. N is the number of trials, P is the probability of success. All right. Now, probably a little mistake in that I haven't actually given you the rule for the binomial distribution. So the rule for our binomial distribution, okay, so the probability that our distribution is equal to some value is given by the number of trials with the number of successes x, NCX, so n trials with x successes, p to the power of x successes, and then 1 minus p to the power of n minus x failures. So what we're saying is the NCX is how many arrangements. That's how many ways, for example, we might be able to have 2 wins from 4 attempts. It could be the first and the second, it could be the first and the third attempt, it could be the first and the fourth attempt, second and third attempt, etc. Okay? P to the power of x is P successes and the 1 minus P is how many failures. Okay, so if we have a look at this example here, we have a large population. The probability of success of somebody being a left-hander is 0.2. And I'm going to take n people out of the sample, so I have n trials of 10. Find the probability exactly 3 will be left-handed. So using my formula, we can have n trials, 10, and I want how many successes? 3 successes, so 10C3. So let's go here, probability that x is equal to 3. 10 trials, 3 successes. Probability of success is 0.2, and I'm going to have 3 of them, which means the probability of failure is 0.8, and 10 minus 3, I'm going to have 7 of those. So if I put that straight into my CAS, I can get an answer. It gives me 0.2013. If we type all that in onto our CAS. The probability at least 9 will be left-handed. So what does that mean? Probability that x is greater than or equal to 9 is equal to the probability that x is equal to 9 plus the probability that x is equal to 10. So I have to do 2 of them. So I've got 10 trials, 9 successes, 0.2 to the power of 9 successes, 0.8 to the power of 1 failure, plus from 10 trials I want 10 successes, 0.2 to the power of 10, 0.8 to the power of 0. Again, use our CAS. So if we add both of those together, we can see we get a very small number. So depending upon what your CAS gave you, mine gave me this, 4.198 e to the minus 6. What that means is it's 0.0000419. Check. So I should be able to move my decimal place 6 places. 1, 2, 3, 4, 5, 6. So the e to the minus 6 means that's how many decimal places I'm going to move it. All right. Finally, part C, more than one will be left-handed. So we've got to think about that one. Probability that x will be more than 1. So it's got to be greater than or equal to 2. So I could go 2, 3, 4, 5, 6, 7, which is the same as 1 minus the probability x is less than or equal to 1. Because all the probabilities got to add up to 0, remember. So it's 1 minus x equal to 0. So I have 10 trials, 0 success, 0.2, 0 success, 0.8, 10 failures, plus 10 trials, 1 success, 0.2 to the 1 success, 0.8 to the 9 failures. And now if we add all those up, I'm going to get, what do we get? 0.62419. Okay, it's just here. Okay, the nice thing about our CAS calculator is that we can also use it to work out our binomial distribution through use of two particular rules. So if in your calculator you go to menu, so let's write it down, menu, probability, then go down to distributions, and then scroll down to D and E. So down to option D and option E, which are Binom, PDF, and Binom, CDF. Okay, and what they do is the binomial distribution, binomial probability density function, Binom PDF. If you put in the key values, it will work out our probabilities. And the key values are, and a screen comes up, and I'll give you a screenshot in a minute. You put in the number of trials, the probability of success, and then the X value. All right. So if we go back to the very first question we did before, where we had a probability of success of 0.2 with our left-handers. So for example 10, to work out the answer for example 10, we had Binom, PDF, 10 trials, probability of success of 0.2, the probability that X was equal to 0.3. The probability that X is equal to 3, or we have 3 successes. And that gives us our answer. For the binomial CDF, the CDF function is the cumulative density function, which gives you an interval of values. So again, we have n trials, the probability of success, and we put in the lower bound and then the upper bound. Yeah. So this one here was the probability that X was equal to 3. And if we went to option example, or the last example, the probability that X was greater than equal to 2, I could put in Binom CDF for cumulative, 10 trials, 0.2 success, and I want from 2 to 10 successes. Okay? There are the two images there underneath. The data we put in, we can get to generate the answers. So if we keep that in mind for examples 11 and 12, let's have a think about on our calculator. A fair die is rolled 8 times, number of 6s is noted. So straight away, we have a certain number of trials. So I've got n is equal to 8 trials. The probability of success is 1/6. Find the probability of observing no 6s. So I'm going to use my binomial. Specific number, PDF, 10 trials, probability of success is 1/6, and I need 0 successes. Okay, and what I'm going to do is I'm going to put these all on our calculator, and we'll just put a screenshot in. And that equals whatever it happens to be. If I only get 6s, So I'm going to roll the dice 8 times and get 8 successes. Binomial PDF, 10 trials. Whoops, it's not 10 trials at all, is it? So there's a mistake there. Mistake go out. So let's just put that in red to highlight we changed it. So we've actually got 8 trials. Probability of success is 1/6, and only 6s means I want 8 successes. The first is a 6 and the rest are not. It's a little bit different. So what is the probability of the first dice being a 6 or the first roll being a 6? That's equal to 1/6, isn't it? And if the rest of them aren't 6s, well, that's 5, 6 by 5, 6 by 5, 6. How many times are we going to do that? We're going to do that 7 times, aren't we? 1, 2, 3, 4, 5, 6, 7, which if you like is 1/6 times 5, 6 to the 7ths. And if I only get exactly 1/6, if I get exactly 1/6, I'm going to use binomial PDF, 8 trials, 1/6 success, 1. All right, so let's put a screenshot of all those in. Hopefully you can see just here over on the right, the key statements that we had to type in to get the relative answers that we needed, okay? What about example 12? In Australian math competition, 30 multiple choice questions, each with 5 answers, only one being correct. The student guesses all questions, find the probability that they get half correct. All right, so again, always identify we call them parameters, but the key features of our distribution. So we're going to say X is distributed binomially. We have 30 trials, and the probability of guessing one of them is a 1/5, okay? So again, I'm just going to go, if I want to write out my rule, so we should be familiar with both, I'm going to have 30 trials and get half of them correct. So that means I've got 1/5 to the power of 15, and that means 4/5 I'm going to get 15 wrong as well, okay? And we'll also do, if I use my binomial, PDF, I'm going to have 30 trials, probability of success is not a half at all. Probability of success is 1/5, and we want 15 successes. All right, again, I'll put a screen dump there on the right to get an answer. Gets at least one correct. So 2 ways we consider at least one. The probability that X is greater than or equal to 1 is also the same as 1 minus the probability that X is equal to 0. And this could be a way you might need to do it. 30C0. Maybe not so much this year because it's all brand new. 1/5 to the 0 successes, 4/5 to the 30, which is the same as 1 minus 4/5 to the 30. Or greater than or equal to, we're going to use binomial CDF, 30 trials, probability of success, I want to keep writing a half, but it's a 1/5, and we want from 1 to 30 successes. All right, so let's do a screen dump of those. You can see from the screenshot down there on the bottom right corner, gets half the numbers correct. 30 trials, 1/5 success, 15 successes, gives me 0.000179. And then at least one correct out of 30 trials. I'm going to use the CDF feature. And we want from 1 to 30 successes, which is 0.99876. All right, off you go. Use both. Use the binomial PDF, CDF rules as regularly as you can, but you need to be familiar with both.